of advanced features. Yeah. Regular features, so we know, do those queries, right? 4 types of queries we learned last time. Yeah. Yeah. But here, we like to see, other than those basic features, there are some more advanced features. Okay, so let me here in this 8.1, I like to describe some of the advanced features. All right. The first one I like to talk about transactions in DBMSs. Transactions. But this transaction, its meaning is different from our everyday life transactions, right? When you go to a bank, yeah, when you do your banking transactions, that kind of transactions, that's your everyday life transactions, right? But here in our databases, we have special meaning here. It's a special type of operations. Here, let me describe how special it is. Yeah, so this is an important concept. Okay, all right. Definition of transactions. So what's the meaning? Define a business task containing a sequence of database accesses that cannot be separated. This one sentence, that's the official definition, but from this one sentence, there are several important points we need to see. Okay, yeah. A sequence of business accesses. Now, accesses here, you can think of those basic query operations. Retrieval, insertion, update, and deletion, that kind of, but it's a sequence. All right, first thing. Yeah. After that, that whole sequence, all the database accesses in that sequence, putting together, you define one particular business task. Okay, there is one specific business task. That implementation is defined in this sequence of database accesses. And that sequence, another thing important, cannot be separated. After you get these points, then you get a basic meaning of transaction. That's the special meaning in our database concept. All right, yeah. All right, so now let me talk about the properties. Yeah. Actually, the property already included in the sentence, but we like to get a little more understanding. Okay, yeah. All right. Here, I like to explain the necessity of this definition, why we want to have this concept, okay? Why it's important. The reason a concept is created for this kind of transaction, because it is important. Now, here I use the example from typical sequence of banking transactions. Here, let's get to the banking transactions. That ordinary meaning banking transactions, but we want to understand the importance of that sequence importance. Yeah. In your banking transactions, you retrieve money from one account, then you make a deposit to another account. All right, this kind of transactions. Yeah. But think about when you do a sequence of transactions for your banking in multiple accounts, if when you work in the middle, suddenly the system breaks down, crashed, the system crashed. You cannot complete your whole work, whole job. So because for your business, you need to do manipulation and you need time, right? When you complete your, a sequence of transactions, and you need some time, but suddenly in the middle, the system breaks. The whole banking system breaks. You may mess up, right? Yeah. So the money you retrieve, but you couldn't make deposit to another account. How do you handle that? Okay. In business, this kind of thing is critical. Okay, it's critical. So in the business world, things like this should be avoided. Okay, must be avoided. Okay? So when a system is built, inside the system, some protection mechanism must be built in, protect against this kind of, disaster. Okay, you can treat, some disaster for your company. Okay, yeah. So this concept is created, transaction concept. The transaction concept that is used by the system to protect the integrity of your transaction. So your transaction cannot be separated. Separation is not allowed. The system has its own internal mechanism to protect you against that breakdown. How? That's another issue. Here you may ask how to do that. I can describe the idea, right? Yeah. In the system, it could be very complicated, but here I just describe idea to make sure your business task is protected in some special way. Yeah. All right, so let me describe that. All right. Here, yeah, so we understand withdraw from account A and the deposit in account B, and we want to treat the sequence of transactions as a whole, cannot be separated. Yeah, so then we generalize to many business activities. We don't want separation. So we use this transaction concept. Yeah, all right. How to implement? Yeah, here, let me talk about the simple idea for the implementation. Okay, all right. First, you need to define your transaction because the system does not know the definition of your transaction. The system is not that smart, okay? The system does not know your business. So you need to tell the system, this is the sequence of activities or database accesses. That's my transaction. So you need, how do you define that sequence? You need to have a big starting point. Okay, yeah. So in Java, we need to start with a begin. We set a begin point, begin of transaction. Okay, yeah. Here I use Java as example. Okay, transaction. Java example, begin. Okay, yeah. After begin, you can define a sequence of queries, okay, basic queries. You put behind that begin statement. Yeah, there is a begin statement, okay? So, all right, but after that, you need to tell the system the end of the transaction, okay? Two endpoints, begin point, end point, okay? Yeah. The endpoint, how do you tell the system after the current query, the end of the transaction? You call commit, okay? Commit activity, all right? Yeah, transaction, commit the transaction, all right, yeah. So a block, you know, here, let's treat the whole block is defined clearly. The system knows the starting point, the end point, all right? Yeah. Then the system has the responsibility to make sure the whole block of code must be implemented as a whole, no separation, as a whole, all right? Yeah. Then consider exception. Something could happen, yeah, the power, the down, you know, server, internet, right? A lot of, you know, tornado, you know, right? So a lot of, you know, natural disasters could happen, right? Yeah. Then catch block. Here I use Java example. So there is a, you know, catch block. Yeah. Because in the catch block, you may have some exception. Okay. When something happens, then you are in, there is some exception. So we're in this catch block. So we need to write some code in this catch block to do something to protect your transaction. Okay, so the catch block, basically, we do one thing called a rollback. Rollback. Okay, rollback. Yeah. So what's that? Rollback. Yeah. Because think about, you are working somewhere in the middle, right? Yeah. So here, we're here in the middle. The system is working on your transaction somewhere in the middle. Okay. Yeah. Not completed yet, but something is wrong. Roll back. Okay. Roll back is undo. Okay. So this part, don't undo. Don't do it because you cannot complete it anyway, right? The remaining part of the transaction cannot be completed. So you have to undo the part that has been done, that part to the beginning point, all right? Yeah. All right, no damage, nothing happens before that beginning point, okay? No damage to protect your business task, okay? Because if you do not do it, no disaster, right? Yeah. When the system recovers, then you do that transaction another time, okay? Yeah. So that's the whole implementation idea, okay? Yeah. You may further ask, how can you undo it, right? Yeah. That's another issue. Yeah. Inside the DBMS, there is a way to undo, okay? Yeah. All right. So inside DBMS, it compiles your command, your database query. Each query is one command. Yeah. It needs to be compiled inside your DBMS to become executable command. Yeah. Because when you write a query, it's a high-level language, right? High-level language, okay, not executable. So inside a DBMS, it needs to compile your query command and to make it a machine code, machine instruction, okay? So a sequence of machine instruction. Put things together, you know, all commands must be compiled one by one and put things together, all right? If nothing is wrong, then make execution, all right? If something is wrong in the middle, undo it. Because the system has not done execution, right? Just preparation, compilation, preparation, okay? That part can be undone, okay? Don't worry, yeah. Preparation, the system does the preparation, not execution. If execution, the whole block is executed quickly, so, you know, extremely fast, the whole block is executed quickly, right? Yeah. Yeah. But when you do preparation, usually it takes a little more time. That part can be undone. Okay, yeah. So that transaction, that's just not, it's not like the first one compiled, executed, second one compiled, executed, then you cannot undo it. Because already executed, how can you undo it, right? You cannot. So it's not like that. The first command gets compiled, executable, and executed. Second, get compiled, executed. It's not like that. If it's like that, then you cannot undo in the middle, right? You cannot, okay? First one, get compiled. Stay there, right? Waiting for second one, get compiled. Stay there in the sequence, okay? Until you get all compiled as a whole. Still, everything is all right, nothing is wrong. Execute together. That kind of, you know, internal mechanism to protect your business task. Okay, this is advanced concept. Advanced concept. Okay, yeah. But in our programming language, we have many ways. So this idea, this high-level idea, you just have this idea in your mind. Then when you try to use different programming languages, the way to implement a little different. In PHP, in Java, they have different ways to implement this idea. But the high-level idea is the same, okay? You need to begin your transaction, okay? Then the definition, then at the end, commit, all right? Yeah, commit. That word could be different. That commit word is used in Java. Java, we call it commit, okay? In other programming language, we may call different name, okay? Yeah. Then there is a rollback. When something happens, there is a rollback. The last thing to protect your transaction. Okay, all right. That's the whole concept. Yeah, rollback if there is an error. Yeah, all right. Yeah, yeah. The properties. Yes, here to summarize. Here to summarize. Yeah, all right. Yeah, I mean I have to, you know, erase a little bit. Yeah, all right. Yeah. Okay. Yeah. All right. Then let me summarize some properties here. Yeah. Isolation property. Oh. Yeah. Oh, Not oh, why? Oh, what's wrong? Stay there for a long time?
Yeah.
Oh. Oh, I wrote a lot of. What's the problem there? Hmm? Oh, why is that? Oh, slow processing. Slow processing. Wow, that's horrible. Hmm. Yeah. Oh, I don't. Yeah. If chat something. Oh yeah. Yeah. Not here. Oh, the Zoom side student. You because they see my screen. What do you see? You see the that screen.
You know.
It's normal. Yeah. Let me check my battery. 46. Yeah. Anyway, yeah. That's not. Let me try again. Oh, yeah. That's. I wrote a lot of things. Yeah. You just listen to me. Yeah. Here. 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 Yeah. Yeah. All right. Yeah. Oh, I cannot erase it. How can I erase it? Yeah. Anyway, yeah. Properties. The properties. Yeah. Yeah. So, all right. Isolation property. All right. Yeah. The first time I had this problem. Okay. First, isolation. What's the meaning isolation? Yeah. Think about it. There are two transactions. Yeah. They must be isolated. Okay. We do not allow interference. Okay. Yeah. Because inside DBMS, the system may need to execute multiple transactions at the same time. Think about that. Multiple transactions at the same time. So each transaction must be isolated. All right. Yeah. All right. Yeah. Even at the same time. So that's the isolation property. All right. No interference from other transactions. That's the isolation property. Yeah. Let me see. I cannot erase. Atomicity property. Atomicity. The second property. Atomicity property. It is treated like an atom. We know in philosophy or somewhere, atom cannot be separated, right? Or ancient philosophy, right? Ancient philosophy, atom is treated as some particle that cannot be separated. All right. Yeah. So here, when you borrow that old meaning, atom meaning, yeah. not in modern science. Modern science, atom can be separated, right? Yeah. So atomicity, that means your transaction must be treated as an atom that cannot be separated. Right? Yeah. So these two properties, two main properties for transaction. All right. Or, yeah, so here it's blocked. Yeah, I cannot erase my handwriting. Or none. Yeah, or none database operations are executed. Okay. Yeah. Or as a whole or nothing. Okay. Executed. Cannot be partial execution. Okay. Yeah. zero or whole execution. All right, so that's the transaction concept. All right. Concurrency. Yeah, all right. Yeah, this one I didn't. Yeah. All right. Concurrency control feature, another important feature, concurrency. Okay, yeah. Because in the business world, yeah, especially when we write our web applications, yeah, many users in the world, they need to access your system concurrently. Okay, so your DBMS need to do data processing and consider that concurrency control. How do you make sure you can handle all those database accesses concurrently without any problem? Okay, yeah, all right. Support several users trying to update the same data to do so in a controlled manner. They access the same data item. Yeah, must be in sequence, right? First sequence, second, third, yeah. Concurrency, but internally, some good control must be applied. Yeah. All right. Concurrency control. Yeah. A good DBMS must include this feature. Yeah. Here, yeah, because I list this, Microsoft Access. We know Microsoft Access it is designed for, home business typically, right? Yeah. Home business, yeah. Probably some very small business, they may use the Microsoft Access to store their business data. Yeah. All right. If you do not do it in web applications, that's fine. Yeah. Because in that situation, you do not need to consider concurrency. If you do not run your system on web, you do not need to consider concurrency. Okay, yeah, your home business. Okay, yeah. But your home business could grow, right? Yeah. Eventually, you may like to put your home business on web. So multiple users, they may need to access your system, make order. Okay, yeah. A lot of activities at the same time. Then this concurrency requirement is important. Okay, here I use Microsoft Access because the older version does not support more than one users access at the same time, no concurrency. Older version, 10-something years ago, older version, no concurrency support in Microsoft Access. Okay, yeah. So then at that time, but some people still, yeah, because they don't know that. Yeah. They wrote, yeah, I know, my student, several other cases, they use Microsoft Access as your web application databases, but they notice one big problem when multiple users access at the same time. Yeah, because their business at some time, suddenly many users, they need to access at the same time, then extremely slow. Yeah. Because no concurrency support. So you have to work one by one, the first user, second user, third, waiting in a line. Yeah. But if you have a relatively long line, then very slow. If with concurrency, yeah, much faster. The processing, using basically multi-threading. You can think about multi-threading type of processing. All users can get response quickly. Yeah. But recent version supports 255 concurrent users. For small business, it's enough, right? Yeah. For, you know, typically for small business, if you expect your users much more than this number, much bigger than this number, you should use more powerful DBMS, like MySQL, powerful. Free, powerful, you know. Yeah. But if you feel you don't need that many users, you know, typically access your system at the same time. Yeah. Your total users may be, you know, much more than that, but most of the time they do not access your system at the same time. So then you will be fine. Yeah. Yeah. All right. So that's the, you know, concurrency property. Yeah. All web applications require this feature. Web application. Yeah. People in the world, right? They can access your system. Okay. Yeah. Suddenly, you know, your system get overwhelmed. Yeah. Even supporting concurrency, still your system could get overwhelmed. Okay, for some reason. A famous hacking, you know, attack, you know, hackers try to overwhelm your system, sending a lot of requests at the same time, large number of requests to your system at the same time. Think about that. Your system cannot handle that. That's the most common attack on web. Okay. Yeah. All right. Yeah. Yeah. The transaction feature requires this feature. Yeah. In order to implement transaction, yeah, we just talked about, well, yeah, this feature, concurrency control feature, must be available. Then the transaction feature can be implemented. Yeah. All right. Think about using Microsoft Access as DBMS for web applications. Yeah. So the old time, current time, the old time, huge problem. The current time, yeah. Usually only small business consider Microsoft Access. When your business grow bigger and bigger, so definitely you need to choose more powerful DBMS. Yeah. All right. Another advanced concept, stored procedure. Yeah. This one, another important. Here, we talk about three advanced features: transaction, concurrency control, and this last one, stored procedures. Procedures, functions. Here we did, in our general programming languages, we define functions. So you have that concept in your mind. But in DBMS, we also need to DBMS. We may also need to write our code to SQL code. When we write code, we use SQL. Okay. SQL, here we treat it as a programming language. Okay. SQL, yeah, we treat it as a special programming language. Okay. Yeah. And we can use this SQL programming language. We can write a function definition. It's a procedure. Yeah. So we call it, you know, stored procedure. Procedure stored in DBMS. Okay. Stored somewhere, right? Yeah. Where it is stored. Okay. Stored as part of the definition of your database. Yeah. For a database, you need to define your database, right? Think about it. You need to write SQL statements to define your database. When you write your SQL statements, you need to define many tables. Other than tables, you have other constructs you need to define, right? Domains, constraints. So we will talk about those things later, okay? Many other constraints. One of constructs, one of the constructs, stored procedure, part of the definition, okay? Yeah. So that's stored inside. Let me use here. All right. Stored as part of your database definition. So we call it stored procedures. Okay, yeah. But later, when you need to move your database from one server to another server, then you need to export your database. Export as SQL scripts. Yeah. So there is a function. Yeah. So you click that button, export your database. Then you save the whole database as a file containing large number of SQL statements. Okay, then you take that file, copy that file, take that file, you move to a different server, then you import, export, and import to a different server. Okay, but when you do that transfer, okay, transfer from one machine to another machine, suppose you have a stored procedure. Okay, the stored procedure is exported, okay, in SQL statements, right? Yeah. Block of SQL statements. Okay, yeah. Then when you import, then execute those SQL statements. So you move your database to a different machine. Okay, yeah. So that kind of thing. Yeah. All right. In form of functions. Yeah. With input and output. So here, let me try to erase a little bit. Yeah, yeah, because I just write some fresh handwriting, so I can erase. But if I get out, then after that I get in, my old handwriting, I cannot erase. So that's software problem. The software is not that smart. It cannot recognize my old handwriting. Yeah, that's the problem. Yeah. All right. Written in SQL store procedure. This part I like to show you some examples. Yeah, last semester I couldn't find time to show, but this semester, because here is still early, yeah, I think I can try my best to squeeze some time to show you some examples of stored procedures. Yeah. And we can add some stored procedures in our databases. Okay, yeah, so let you feel about it. Yeah, written in SQL, yeah, execute a sequence of SQL statements in DBMS. Yeah. You just imagine a typical function definition, but this function is written in SQL language. Okay, yeah, part of database definition, and we call it metadata. Yeah. Because the database definition, we treat it as metadata. What's the metadata? So when you see this meta, so its basic meaning is description or descriptive data. Okay, yeah, because this data is not our primary data. Okay, yeah. Metadata, not primary data. So we have our primary data. Yeah, probably I'll talk about later. Primary data, and we have secondary data. Primary data, that's our business data. Second data, metadata, descriptive metadata, supporting data. You can treat it as supporting data. Okay, yeah. All right. Can be called locally and remotely from the application program. So this part also interesting. Locally, that means same machine of your DBMS. Your DBMS running on some machine, right? Same, yeah. Locally here we mean you call it from same DBMS machine. Okay, yeah, locally. Remotely from different machine, remote call. Yeah. And you need to do that remote call. Okay. Because we may need to write large web applications. We know many large web applications, they are running on multiple servers, not just one server, multiple servers. Yeah, because the web application is so big. Okay, yeah. Each server runs some of the features. Okay, but they have so many features. They need to combine large number of servers in the world and put all the features together to make a huge system. Think about that kind of huge web applications. Then you have a chance, you need to call store the procedure remotely from, not from your machine, from a remote machine. Okay, yeah. So here we can do that. Okay. So in our high-level programming language, PHP or Java, we can call. Okay, we can call store the procedure from remote machine. Very convenient. Okay, yeah. All right. All right. Can be created in application program. Here, another capability can be created. We need to create a store procedure. We want to create a store procedure. What do you mean create a store procedure? Write a definition of store procedure. That's the creation. Write definition of store procedure. Okay, yeah. But now we do it remotely. Okay, we do not do it locally on the same machine running the DBMS, remote machine. Okay, yeah. So we use some application program, Java or PHP application program. Okay, so here I use, two examples: Java example, PHP example. Okay, yeah. Then inside my Java program or PHP program, I want to define a stored procedure on a remote server. Okay, how can I do that? Yeah. I just execute a sequence of SQL statements. Because in my Java program or PHP program, I can run SQL statement 1, 2, 3, all right, one by one. And those statements are put together. They define one stored procedure. How about that? Okay, nothing is wrong. It has the capability. Okay, yeah. So here, basically, I give you the capability. Yeah, because it's hard for me to show you examples for everything I talk about, right? We don't have that much time, okay? I can show you some of the examples, but still, many things I describe, I cannot show your examples. Although I like to do that, yeah, we don't have that much time, okay? Here, I just give you the capabilities, okay, yeah, all right. Can reduce data traffic on internet. Another, reduce data traffic on internet. How can you see that? Reduce data traffic on internet. Okay, all right. Here, let me just describe simple idea here. Okay, all right. Server 1, server 2. All right. Server 1, you have part 1 of your web application. All right. Server 2, you have part 2 web application. Okay. Yeah. But for your web application, they need to work together, right? Part 1, part 2, they need to work together. Sometimes you use part 1 features. Sometimes you use part 2 features, right? Yeah. But when you make them work together, do you need to send the data back and forth? Okay. You may need to pass data back and forth, okay, between machines. That's a lot of internet traffic. A lot of internet traffic. Okay. All right. So here, let us imagine we want to do database queries on a remote machine. Okay. Now here, the situation is do database queries on a remote machine. All right. Imagine these queries need to manipulate large amount of data. Large amount of data. That's possible, right? Yeah. All right. A sequence of queries. Large number of data. Think about if you are in one machine, you need to do a sequence of queries in a remote machine with large amount of data involved. Okay, yeah. But you need to manipulate the data at your side. Yeah. So your side, suppose this is your side. Okay. Your side. This is DBMS side. They are at two different sides. Okay. Yeah. Far away in the world. Okay. Far apart. All right. Yeah. Then, but you need to manipulate the data. You do query 1. You need to retrieve data. Send from DBMS side to your side. Data transfer. Then you work at your side. Then some more data sent back and forth between two sides. A lot of traffic, right? A lot of internet traffic. How do you avoid that? We know if you need to do large amount of data traffic, it's slow, right? It will be slow, all right? How about, think about, that's the first idea. Okay, not very good. Second idea, why we need to get data loaded to our side? Why we need, can we just let the DBMS do the database processing at DBMS side? Do not send here, only send us final result. Do not send us intermediate result. Do not send us intermediate data. Only send us final result. That's all we need. Okay. So here you can do that with a stored procedure, because your stored procedure is a program. the program can do a lot of manipulation, right? Just write a stored procedure to do all the manipulations at the DBMS side. Then at the end, send the final output to our side, reduce traffic, right? All intermediate data transfer is gone. We don't need that part, okay? We just need the, final output, okay? That's the meaning can reduce data traffic on internet. Yeah. So you can see this advanced feature, very useful. Okay? Yeah, here I just tell you the capability. Yeah. So later, you may have a chance, you need to do that in your company. Okay. Yeah. After you graduate, when you work in a company, you may have a good chance. You need to write some stored procedures or call stored procedures. Okay. Yeah. All right. I will show you a few examples. Yeah. Okay. Yeah. All right. Yeah. So here we have that 3 advanced features. This part. Yeah. All right. Yeah. Can enforce business rules. Well, enforce business rules. This property I will talk about, because later we will talk about business rules. At that part, so I will, get to this one another time. Yeah. Enforce business rules with stored procedures. All right. Yeah. Then 8.2, yeah, another part. Yeah. Yeah. We pretty much run out of time. Yeah. All right. Define a database. Yeah. 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 Here, yeah. Let me just do one slide. Okay. Yeah. So the remaining 5 minutes, let me just do one slide. Yeah. The good thing is my battery life, looks fine. Only the last 5 minutes. We won't lose much. Yeah. Yeah. But the part we lost, that presentation, that part. But I believe that's this machine problem. On my laptop, on my recording, it's fine. If you go back to watch the video, that's probably fine because that's from my laptop. Okay, yeah. So that part you can get back. Yeah, yeah, but still messy because I erased things. Still a little messy. Yeah. How to specify a database structure? We need to describe the structure. So what's the structure? Tables, your table definitions, and other constructs. Yeah. Table, typically our main construct. Yeah. Data types, you need to describe data types. Okay, integer, string, yeah, string, we have specific data type for it. Yeah. Constraints of data. Yeah. The data, because the data you need to provide a range for your data. So constraints, yeah. Many different constraints. Yeah. Then metadata, descriptive data, metadata. Okay, yeah. Actually, all these things belong to that metadata. Okay, so when we write the database definitions, all our definition part goes to the metadata. The part not metadata, just the business data itself, original business data. Yeah. That's the, we say primary data. Okay, here, descriptive data for your business data. Yeah. So this is your business data. Business data. Okay. Refers to database definition. All the definition things, all those SQL statements we treat as metadata. SQL statements, all those things, definition. Okay, yeah. All right. Stored by the DBMS in the form of a database catalog. There is a concept called a database catalog. Catalog. Okay, or dictionary, yeah. So here, the catalog concept. Okay, inside DBMS, there is one special part inside DBMS. Yeah. Store all those database definitions. So that part, database catalog. Okay, yeah. The metadata stored there. So not your business data directly, yeah, indirectly, descriptive, supporting data, the catalog part. Yeah. All right, yeah, all right, yeah. So let me just stop, yeah, right here. Yeah, I think, yeah, I will finish this one quickly. Yeah, but the good thing is, we complete that 3 big advanced features. 3 big advanced features. Very big. Okay, very important, very big. Yeah. Okay, yeah. Actually, among those 3, because concurrency control, you do not need to do anything, right? You only need to know that concept, concurrency control. For you, you do not need to do anything. Okay, so among those 3, concurrency control, nothing to do. All right, but for transaction and for stored procedure, you may need to write a code to do those features. Transaction, you need to define your transaction, and you need to execute your transaction. Store procedure, you need to create your stored procedure, and you need to call stored procedure, right? Yeah. All right, so you just focus on transaction and stored procedure. Those 2. Okay. Concurrency control, you just know it. Okay, you know it. You do not need to do anything on it. All right, so that's it. Yeah.